Case N involves an archer shooting 9 arrows. It's a binomial distribution problem because each arrow shot or each shot is regarded as independent of the previous one, and we want to just know how many bullseyes the archer might hit in 9 tries, or 9 arrows to be shot. Part A asks what's the probability of 2 or exactly 2 bullseye shots. In Part B, the question is instead asked what is the probability of at least 2 bullseye shots, and C, what is the expected number of bullseyes scored with the 9 arrows. So when we begin this problem, before we begin it, let me just remind you that for the binomial coefficient, when we have n upon k, we get something that's equal to n factorial over the quantity n minus k factorial k factorial. And the one thing that's weird is when k is equal to 0. Remember that 0 factorial is equal to 1. With that, we'll go ahead and use the we'll use the binomial distribution in order to calculate the probability that exactly 2 are shot. That's going to be equal to 9 upon 2 raised to the multiplied by 0.09, and there are going to be 2 bullseyes, plus 1 minus 0.09, which is equal to 0.91, which is raised to the 7. Because 7 of the shots are not bullseyes, 2 of the shots are bullseyes, and this answer is equal to 9 factorial over 7 factorial times 2 factorial, and then we have the other two terms, the 0.09 squared and the 0.91 raised to the 7th. When I calculated this, I got that's equal to 9 times 8 divided by 2, because the 2 factorial reduces to that, and .09 squared, 0.91 raised to the 7th. I got an answer here of 0.150688. The second part of the question asks for the probability, so B asks for the probability of at least 2, so 2 or more, and that's what that means. But to do that, I'd need to calculate probability that's 2 and 3 and 4 and 5 and 6 and 7 and 8. I'm too lazy, I'm not going to do that. So that's the same as saying that it's equal to 1 minus the probability that x is less than or equal to 2. And so in my case, our case, that's just 1 minus the sum that x is equal to 0 plus the probability that x is equal to 1. So this is the one that we're going to evaluate, this version right here. And now I need the probability that x is equal to 0. The probability that x is equal to 0 is found as, in this case, there's only one way that can happen. We have all non-bullseyes. What's the probability of that? 0.91 raised to the 9th. There's only one combination, and that's that. So we have the probability that x equals 0, and when I used a calculator to calculate that, I got 0.42793. Next, I need the probability that x is equal to 1, and to get that, I take 9 minus 1 9 factorial over 9, let's see, let me just do this a straightforward way. 9 stacked upon 1, 0.09 raised to the 1, 0.91 raised to the 8. And that's equal to 9 times 0.09 times 0.91 raised to the 8, and all of that is equal to 0.380905. So I get the probability that we get 2 or more is equal to 1 minus the quantity 0.42793 plus 0.380905, and I got a probability that x is greater than or equal to 0. No, whoops, 0.191165. Lastly, the last part of this problem, we were asked to find the expected value of x. That's equal to the mean of the number of bullseyes shot with 9 arrows. That's just equal to p times x. Sorry, this expected value is equal to n times p, and that's equal to 9 times 0.09, which is equal to 0.81. So on average there are 0.81 bullseyes in 9 arrows, and that's the end of this case.